Hello everyone, today we'll talk about the solution to the problem split a string into the max number of unique substrings. Now, of course, if you look at the constraints for the problem, you'll see that this is a exponential time complexity intended solution, so probably a backtracking problem. But this problem might seem at first glance to be something similar to dynamic programming, because typically if we want to, in this case, split a string into some parts, then dynamic programming would help us if we could, by knowing the answer for some prefixes. So for instance, if we know that the first half of the string, we can split it in the best way into some number of substrings. Then if we can extend that solution to a solution for a bigger prefix, then finally we can extend all those solutions into the solution for the whole string and then get the answer for the whole string. However, this constraint that we have here, that all the substrings must be unique, is what's preventing us from using dynamic programming here, or at least prevents us from solving this problem quickly using dynamic programming. That's because for us to be able to tell if we can indeed extend the string with another substring, we have to know exactly what split we performed on the prefix that we had. Because there may be, for instance, multiple splits that give us, let's say, 3 substrings, but only one of them, or some of them, but some of them are not able to be extended by a substring that we're currently looking at. To check if the new substring is unique, we have to have access to all the substrings before. And there may have been very many possibilities of splitting those substrings. In particular, maybe we can split the prefix into a fewer number of substrings, such that we can later split the suffix into some substrings. So yeah, because of this specific constraint, dynamic programming will probably not work, but luckily we can solve this problem using backtracking. And again, when it comes to backtracking, the general form, especially when it's a 2 to the n backtracking, right? So this is the type where you essentially, for every element that you have, decide if you take it or not. In this case, we're deciding on splits. That's the same thing. In particular, we can think of a split. So when we have a string and we're at this position, then the question of whether or not to split at this position or not is the same thing as deciding whether or not this element we should take to be part of the previous block or not. So that's the same thing as just deciding to take or not take an element. This will lead to a solution with complexity 2 to the n. And the general form is this. We'll be maintaining a current set, in this case it's literally a set, that will hold all the words that we've seen already. We'll have a recursive function that will calculate the results, so at the end we just run it and return the result. And whenever we want to recurse, we add a new word to our set, we recurse and maybe update our result, and we remove that word from the set. Typically when the decision is simply binary at this position, we have the recursive call, then we add an element, we recursive call again, then we remove the element. In this case, since we're looking at it based on what length of the string we're currently looking at, so we're deciding how many characters to take from a given position in a string. So that's the parameter I that we have here. This is how many elements were already used in the beginning, and that prefix has been split correctly. Then we can just decide what the right end of that string is. So maybe j is here, and then j is here, and then j is here. So we decide on what this string will be. Of course, we have to make sure that that string from I to j is not currently in our set, because if it is, then we just continue to the next j. And if it wasn't, then we add it to the set and we recurse. And of course, our base condition is when we run out of the string, so the I points to after the end of the string, we return the length of the current set, because this is the set of all the words that we've split the string into. So this is standard 2 to the n backtracking, following the standard way of writing such solutions.